All right, so I had another video planned for you, but then I realized it might be helpful for me just to go through some of the problems that are on your homework assignment so that you could see that and be able to reproduce that as you're doing the rest of your homework. So let's start off with problem number 1. And problem number 1 reads that f of x equals 2x plus 1, that entire thing to the 5th power. All right, so no need for a rewrite. F prime of x then equals, there is an invisible 1 in front of that, so 1 here. So bring the power down. Here's your brick. Raise this to the 1 less power, which is 4. Notice in this process, you've done a derivative. You brought the power down, 1 less power. That is a power rule, so the inside has to stay the same. Times, now this brick has to disintegrate. You're going to take the derivative of your inside, which is just 2. All right, so you want to combine things that have like powers. This 1 is to the 1st power, the 5 is to the 1st power, this 2x plus 1 is to the 4th power, and this 2 is to the 1st power. So your derivative, some people feel comfortable with you writing things with like powers right next to each other. And that's fine. So I can combine those, right? So then my derivative, f prime of x, equals 10 times 2x plus 1 to the 4th power. All right, so let's move now to problem number 3. And number 3 reads that f of x equals the square root of x to the 4th power plus 8x. Now you notice it doesn't look like this entire chunk of information inside the radical is to a power, but it is. There's only one of them. So we can make that to the 1st power. Hopefully you can see that. And it's implicit if it's square root, that is root 2. So then as a rewrite, again, not a derivative yet, this equals x to the 4th plus 8x to the 1/2. Again, the 2 is going to travel underneath and sit underneath that 1. Okay, so now we're ready for a derivative. So then f prime of x equals, again, there's an invisible 1 right there. So you pull the 1 out, 1/2, and here's your brick. You can't change this because it's chain rule to the negative 1/2 power. So bring the power down, 1 less power. The inside has to stay the same because we already took a derivative. Bring it down, 1 less power. That's that last power rule that we had. So x to the 4th plus 8x. Do not change that piece. Not the first time around. Make it a little bigger. Times, now the derivative of the brick has to come into place. So the brick has to disintegrate. And by the power rule, this is 4x to the 3rd power plus 8. Just like that. All right, so what can we combine? This 1, that's to the 1st power. The 1/2, that's to the 1st power. And then also you can combine the 4x plus 8, that's to the 1st power. 1st power, 1st power, 1st power. So you can put those right next to each other if it makes you more comfortable. Okay, the 1's not going to do anything, but 1/2. And then we have 4x cubed plus 8. Let's put that over 1 since dividing by 1 doesn't do anything. And we also have x to the 4th plus 8x to the negative 1/2 power. Okay, so we're getting there. 1 moment, please. Grab some more paper. All right, so you can multiply straight across here, multiply straight across there in order to combine those. Let me move that up for you. So then you get that f prime of x equals 4 x cubed plus 8 all over 2. And then you want to simplify this because, as I mentioned, I don't allow negative or fractional power. So let's do it in steps. Times 1 divided by x to the 4th plus 8x to the positive 1/2 power. So that deals with this negative power, right? Shifting to the denominator. So now I have f prime of x is equal to, okay, if it makes you uncomfortable having 4x to the cube plus 8 over 2, then yes, you can do 4x cubed divided by 2, and also 8 divided by 2. That'll give me 2x cubed plus 4 in the numerator. Of course, there's just a 1 left over in the denominator. If I do that, and then that's multiplied, I'll do it in steps so that you can see what's happening. 1 over the square root of x to the 4th plus 8x. Like that. Okay, now that looks absolutely awful, so I'm going to rewrite that for you. So your f prime of x then equals 2x cubed plus 4, right, divided by 1, times 1 divided by the square root of x to the 4th plus 8x. Notice there's a 1 here and a visible 2 there. Of course, you can combine that even further by multiplying straight across for the numerator and denominator. So then your final answer would be 2x cubed plus 4 over the square root of x to the 4th plus 8x. Okay, so there's problem number 3 in your homework assignment. The next problem I want to look at is problem number 6. Okay, so far we've done 1 and 3. Okay, so problem 6. Okay, problem 6 originally reads as such. F of x equals 1 divided by the quantity x squared plus 7x to the 6th power. All right, let's rewrite this as 1 times x squared plus 7x to the negative 6th power. Okay, so notice this is 1 over 1. I'm not moving the number around at all. That's what's giving me the 1. And this chunk of information was in the denominator. I'd like to bring it up so that I have something raised to a power in the numerator. All right, so now we're ready to take its derivative. So then f prime of x, or the derivative of f of x. Again, this is your slope generating machine. It's called your instantaneous rate of change, f prime of x. Okay, so what we're going to do, we're going to bring this negative 6 and multiply by the 1. Negative 6. Here's my brick. I got to be careful. I want 1 less than this negative 6, which brings me to negative 7. The inside has to stay exactly the same. X squared plus 7x. And the reason you're doing that is you don't want to do 2 derivatives at a time. And when you brought the power down 1 less, that was a derivative. That is power rule. So you can't touch this inside chunk of information the first time around. But the inside brick does disintegrate for this last piece when you multiply, and this is multiplication, by the derivative of the inside, which is 2x plus 7. Okay, so let's see. 1 to the first times negative 6 to the first times 2x plus 7 to the first. So if you were to write that out, f prime of x then equals negative 6 times 2x plus 7 times x squared plus 7x to the negative 7th power. Okay, now some of you guys are probably becoming really skilled at this. So I'll go a little bit faster than I have been going. So this negative 6 distributes to both of those, and I get negative 12 minus 42. times, and then here I get 1 divided by x squared plus 7x to the 7th power. All right, so this is over 1. You can always divide by 1 and not change your entity. Okay, it makes it a little bit easier for us to simplify because I truly am simply just multiplying straight across, right? So in this case, f prime of x equals negative, looks like I failed to write down the x here, negative 12x. Negative 12x minus 42 all over x squared plus 7x, the quantity 7 to the 7th power. Okay, please note that I am flawed, so it is likely that I may make an error as you go along. If you see that, then you can always shoot me an email and I can make the necessary corrections. All right, so let's look at problem number 8. And then I think I'm going to stop on that one because I'm running out of time on my camera. 2 over 3 times 2x plus 9 cubed. All right, so the rewrite on this is simply, remember I said leave the numbers alone? 2/3 times 2x plus 9 to the negative 3 power. Okay, so then f prime of x equals 2 over 3 times negative 3. Here's your brick. 2x plus 9 to the negative 4. Now, notice multiply. The brick disintegrates. Derivative of 2x is 2. Derivative of 9 is 0. Right, so I'm going to put this negative 3 over 1 and this 2 over 1 because I can combine that, and that. So then f prime of x then equals, multiplying straight across, 2 times 3 is 6 times 2 is 12, so negative 12. In the denominator I get 3 times 1, which is 3. And I'm multiplying, didn't give myself a lot of space, by this piece here, which is 1 over 2x plus 9 to the 4th power. Right? So let me separate these. That piece, multiply it by this piece. So then if I wanted to simplify that further, I could. F prime of x equals negative 4 over 2x plus 9 to the 4th power. Let me show that to you.